Welcome to The House That's STEM Built, a regular series where we will discuss the science, technology, engineering, and math that goes into the design and construction of this family home. This is The House That's STEM Built.
In today's video, we will look at the concept of air and water flow from the 8th grade physical science unit on forces in fluids. Specifically, we will address these curriculum outcomes. 3092, describe the movement of objects in terms of balanced and unbalanced forces. And 3094, explain qualitatively the relationship among pressure, volume, and temperature when liquid and gaseous fluids are compressed or heated.
In this episode, we'll explore the concepts of force, pressure, and volume as they relate to the movement of fluids in a home. Air pressure might not be something you think about as vital to your day-to-day life, but it is essential for maintaining your family's health and safety in your home. Did you know that without a proper ventilation system installed in your home, such things as mold and mildew could build up, and you and your family could get very sick?
During the construction of a house, there are various things that can be done so that the proper levels of air pressure can be maintained in the completed structure. One of these is the installation of an HVAC system. HVAC is an acronym that stands for heating, ventilation, and air conditioning. It's basically a system that heats and cools the air and moves it around the various rooms and living spaces of a house, usually through metal pathways called ducts hidden in the walls, ceilings, and floors.
The HVAC system provides heated or cooled air, which is then sent through the network of ducts to the various parts of the house. These ducts are known as the supply ducts since they are supplying the new or freshly conditioned air. When this freshly heated or cooled air enters a room, it pushes the already present air out of the room into another set of ducts. These ducts deliver or return this used air back to the main heating and cooling unit. That's why these are known as the return ducts.
Another way that construction professionals can maintain air pressure within a home is by installing an air exchanger. Air exchangers are devices that move fresh air into the house and stale or stagnant air out. These air exchangers use one fan and vent system to push indoor air outside, while another fan pulls fresh air in.
Have you ever felt an odd breeze or random rush of air moving in your house? Do you sometimes hear whistling sounds and other strange noises? These phenomena are the result of negative air pressure. Negative air pressure occurs when the pressure of the air inside your home is lower than the pressure of the air outside the home.
One way to experience negative air pressure is by standing next to an exterior door or window that is slightly opened. If you put your hand up against the opening and you feel air blowing in on you, that is the result of negative air pressure. However, there are other ways that negative air pressure can occur in a house.
In previous videos, we learned about how insulating a home keeps the home nice and warm in the winter and cool in the summer. However, improperly insulating a house can restrict the flow of fresh air into the home. Fresh air is a good thing in a home, while stale, stagnant air is not. In a sense, a house needs to be able to breathe, much like a person does, and regularly exchange its used air for new air. If a house is improperly insulated by covering up the vents or openings that allow this exchange of air in the house, it won't be able to breathe as efficiently as it should.
Devices such as bathroom vents, range hoods in the kitchen, and clothes dryer vents also push out stale or moist air from a home. Imagine how much damp, smelly air would be trapped inside your house without these devices. The amount of air being pushed out of a home by these devices is significant, and there is no easy way for replacement air to re-enter the home. This creates negative air pressure, which means the home prioritizes trying to suck air in rather than push it out.
The effects of negative air pressure depend on the season. In colder months, negative air pressure draws cold air in, cooling down the house and therefore increasing heating costs. The air inside the house becomes drier and causes dry skin, chapped lips, and static electricity. In the warmer months, negative air pressure draws in hot air, warms the house up, and increases cooling costs. The warm air coming in may cause condensation, creating problems such as mold or deterioration of the home's building materials. So how do we fix the problem of negative air pressure? The main solution is to bring in additional air from outdoors into the home to compensate for the larger volume of air exiting the home. This is done through installing a fresh air intake duct into the furnace area or return air ducting, or by installing a mechanical ventilation system such as an HRV, heat recovery ventilation system.
The HRV can be incorporated into the HVAC system within the home with the use of a simple air intake duct. This will solve the problem of negative air pressure as well as limit the risk of carbon dioxide poisoning in the home.
Air isn't the only fluid whose travel throughout your home is important. Water is another fluid that is very important to the safe and comfortable functioning of a home for things like cooking, cleaning, and waste removal. So, how does water pressure and the flow of this important fluid work in a home?
When you turn on a faucet in your home, you expect the water to flow at a certain rate. Water pressure in a pipe is what causes that water to flow. If your home is in a town or city where the home is connected to a water supply system, the water pressure is controlled by that system.
If your home is in a rural area, it accesses fresh water through an underground well system. The water being drawn from underground may need to be pressurized or pushed along with additional force in order to make it into your home and be useful. That is the purpose of a pressure tank.
A pressure tank in a water well system creates water pressure by using compressed air to bear down on the water. When a valve is opened, water is pushed out of the tank through the pipes because of this pressure. When the water pressure in the tank drops below the required amount, a pressure switch is activated, turning on the pump. The pump then refills the pressure tank with air. The combination of the pressure tank, pressure switch, and the pump causes water to flow through the home.
The pressure tanks in most homes keep the water pressure levels between 40 and 60 psi, pounds per square inch. If the pressure drops below 40 psi, the pump turns on and brings the pressure back to 60 psi again. Because the tank works as a reservoir of water within the house, when water is needed for things like showers, baths, or washing dishes, it can be drawn from the tank without the pump cycling on and off every time the water is turned on.
So how does water pressure work in cities? Homes without a well rely on a municipal water provider. Many areas utilize groundwater sources, but surface water such as reservoirs, lakes, and rivers make up the bulk of the municipal supplies. Whatever the source, the water supply is pumped to treatment facilities for cleaning and purification and then to pressure tanks located at various points throughout the city or town.
In many communities, tall water towers are used. The height of these tanks relative to the distribution area, along with the water's weight, is what generates pressure. The higher the tank, the greater the pressure. Maybe you've seen these tall water towers in your community.
The pressurized water moves from the tank into large underground pipes called water mains that feed the community. Depending on the size of the community, booster stations may be located throughout the area, which use pumps to maintain pressure in the distribution system.
When the water in the water main reaches your house, it branches off into a smaller diameter pipe called the water line or supply line and enters your house underground. The supply line is buried deep under the property to try and prevent it from freezing. It runs from the ground directly into the home. Supply lines are usually made of plastic, galvanized iron, or copper.
Once inside, the water supply line splits into two different pipes. These are called the hot and cold service lines. The one designated as the hot service line runs into your water heater to have its temperature increased to a safe level for baths, showers, and washing dishes. The cold water line bypasses the water heater and branches off to every water appliance in the home. Plumbers install these pipes in straight, 90-degree angles or slightly downward slopes to facilitate easier flows.
When the water for the hot water lines enters the hot water heater, a sensor in the base of the tank sends a message to the heating element. The element applies heat to the tank, warming up its contents in the process. After warming the water heater releases it into the hot water service lines.
Water heaters take time to heat water, but they also preserve a quantity of hot water for immediate use. When you run out of hot water after a long shower, you used up your water heater's reserve. Your water won't be able to heat up again until more water enters the tank, and the tank's element activates.
Each water appliance in your home, like sinks, toilets, and washing machines, has its own intake pipe, which branches off from the cold water pipes to supply it with cold water. To get to each appliance, the pipe must run throughout the home, sometimes requiring hundreds of feet of piping, depending on the size of the house.
A good example of the importance of water pressure occurred in Texas in February of 2021. After a major winter storm, millions of people were left without water. The reason was because people were letting their faucets drip to try and prevent their pipes from freezing. Everyone dripping their faucets caused a massive surge in water usage, causing the water pressure to drop.
When water pressure drops below acceptable levels, thousands of miles of old underground pipes that have holes and cracks can allow groundwater to leak in. Groundwater can have harmful bacteria. Therefore, municipalities cannot guarantee the water is safe to drink. This led many districts in Texas to give a boil water advisory, where the residents had to boil their water to make sure it was safe to drink.
In this video, we looked at how air and water pressure work within a home. Specifically, we looked at the problematic effects of negative air pressure within a home and how this can be fixed. We also looked at the importance of water pressure within a home and how it travels to and from the city's water system or a personal well.
What kind of water and airflow systems does your home have?